Hey everyone, last video I upgraded my headlights on my Ti-30 scooter to these here. What I'm going to do now is get rid of these side lights. I hate these things. They come on with your headlights. You can't turn them off. You can't make them stay a certain color. So I'm going to get rid of these things and replace them with an RGB system, which consists of a controller that the remote talks to, and this controls the LED strip. Before I get started, there's going to be two different ways you can do this upgrade that I'm doing here now. And I did it one way specifically because I have upgraded my headlights to these. I highly recommend them. They're far better than the stock ones. They cost $25. You need nothing else other than to order the lights here. I'll link that headlight video down in the comments if you want to look at that. But anyway, they have these halos on them, and I had a choice when I hooked these up: either have it so the halos come on along with the headlights when you turn on the headlight switch, or put the halos on a separate switch so I can turn on the halos without having the headlights on. And that's what I chose to do. I repurposed my Eco Turbo switch. I just basically do not have Eco mode anymore. I'm always in Turbo, that's what I want anyway. So I reused this switch here to be able to control the halo lights on the headlights here. And I also want to use that same button to turn on the halos and also to turn on these new RGB lights. If you didn't upgrade your headlights and you're going to still stick with the stock ones, you don't need to do part of the video where I'm explaining how to hook up the side lights to the wiring, the push button here. Or if you did upgrade to these headlights, but instead of separating the halos from the headlights, you just tied them both together so that your normal light switch will turn on both your headlights and the halos at the same time. If you did it that way, or if you didn't do this at all, then there's going to be part of the video that you can skip over, and when I get to that point I'll let you know. So to start with, I'm going to disable these side lights. You want to make sure that your LED strip is off. It's not turned on, and if it's off, there's no voltage going to it. So if you look at the end of the LED strip that's closest to the rear of the scooter, and we look on the inside, we'll see that cable there going to the side of the chassis. That's going out to the LED strip. So all you need to do is get that cable and again, make sure the lights are turned off, and then you can just cut right through that cable. I cut the wire, and really the main reason for me to do that was I'm going to completely remove the strip from the side, so I'm going to need to get that wire through the hole. If I follow the other end of the wire that I cut, it goes back to a 2-pin connector, which then in turn goes to this grouping of cables here. So anyway, I'm just going to disconnect this here now, just to get this piece of cable out of the chassis, free up some room. Okay, so I unplugged that. This side of the cable is going back into the wires there. I'm not going to use anymore, but I will put a piece of tape or something over it because there will be positive battery voltage and negative battery voltage on these connectors when the headlights are turned on. So you want to tape that up so it doesn't accidentally short against something. And the side that I just pulled off, the cut piece in that connector, I'm not going to be using anymore, so I'm just going to set that aside. I've done that on both sides now, so I have 2 extra chunks of wire with 2-pin females on it that I'm just going to set aside. And now I just have loose wires like this going to my LED strip outside on both sides. Next thing I want to do is physically remove these LED strips from the side of the scooter. They're held in by a screw at each end. It's just threaded in there. There's no nut on the other side, which makes it real nice. Same with the deck screws on the scooter. They all thread into the deck, so there's no nut on the bottom. I really like that. So these are actually held on by Phillips head screws, so they come out nice and easy. There's one off, there's the other. Here's our plastic covering. Here's the light strip itself. The wire sheathing was bigger than the hole, so that was going to fit through the hole. So I ended up just pulling on this and pulling the 2 wires completely out of the sheathing. That stayed on the inside chassis. Of course, then I could just pick that up and get it out of there. Did the same with the other side, so now I've completely removed the side lights. I'm left with some holes there. What I normally do, I could either fill them with some sealant, but I found what I like to do easier and quicker is get some sort of stickers or something to cover up the holes. If nothing else, I've got some black grip tape. I could cut some very small pieces and put it on there, and it wouldn't even be noticeable. And that would seal up the holes as well. Before I actually mount the lights, I want to hook up the entire system and make sure that they work. So this is a controller, the LED controller that I'm going to be using. And starting off, we look on the input side. The input voltage can be 5 volts to 12 volts. The thing about these controllers is, and they're all the same as far as I know, whatever voltage you put on the input, that's going to be your voltage on the output too. So this can run at either 5-volt system or 12-volt system depending on your input. And your LED strip is going to be one or the other, either 5 volts or 12 volts. So if you're running a 12-volt input to the controller, you have to have a 12-volt LED strip. If you're running 5 volts input to the controller, you have to have a 5-volt LED strip. So that's very important. Starting with the input voltage, I need to pick plus 5 or plus 12 volts. I've already thought about this, and I'm using plus 5 volts because I have an existing DC to DC converter that can take an input of between 36 and 100 volts and outputs 5 volts DC. So I need to do that. There's no 5 volts inside the scooter, so you have to make it with a converter like this. Since I already had an existing 5-volt converter, I'll put down in the comments a link to this one here on Amazon. You can really get any kind, but you have to make sure that the input voltage can be at least as high as the battery of the scooter will go. So the battery fully charged in the scooter is 67.2 volts. So let's say if you want something that takes in at least 68 volts. And you can see on this one, it can take in anywhere from 8 to 85 volts. We can use this from our battery to power this, which then will drop it down the output to 5 volts. Now on this one here, you'll have to look to see, I'm sure there'll be different labeling on it to show the input of the output. I'm assuming from this picture, this is the input, your negative battery voltage, your positive battery voltage. So follow along with my video on how to connect that up. Your output, however, has a USB connector on it, which you're not going to use, so you're going to want to cut that wire off. And there's going to be 2 wires coming out of there. They're either going to be black and red or black and yellow. Either way, the black is negative. The red or the yellow would be the positive voltage coming out of it. So cut that off, strip the wires back, and look for your 2 wires, see what colors they are. This one's $13.99 on Amazon right now. It's not very expensive. And again, you're confirming 8 to 85 volts, which is the input, to 5 volts. I ordered 5-volt LED strips because this is a 5-volt input. So you always have to match your LED strip input voltage has to match whatever you're inputting into your controller. So at this point, if you're wiring this up the way I did, using what used to be your eco switch, the yellow button there, to instead run your halos on your headlights, and also you won't go on to run the side lights here, you can go ahead and jump forward to what shows on the screen right now, and that will be the start of doing it that way. If you're not doing it that way, in other words, you're not using your eco switch to control your lights, then continue watching from here, and I'll show the alternative way for doing that. First, I'm going to go through hooking up the DC to DC converter. If you order this one or one similar and you're not using your yellow push button, the eco, what was previously the eco mode button, to control your lights like I am doing, and you just want to turn the LED strips on and off using the remote control that will come with the controller. So first, I recommend disconnecting your 2 battery connections from your controllers. So unplug the battery from the controllers so there's no voltage going into the controllers. There are capacitors in these controllers that hold a charge even after they're unplugged. So what I normally do is I'll turn on my headlights and leave them on, then unplug the battery from the controllers, and the headlights being on will drain all the remaining voltage on those capacitors off. So once you've done that and disconnected your battery, you're going to want to take the input to your DC controller. This red and black wire here is the input, and its input is 8 to 85 volts, so that's going to be our DC input. We're going to connect this to it. We want to connect this to our battery voltage directly. So if you look at your 2 controllers, mine, it was the one closest to the battery. Now they could be reversed. What you're looking for is this isn't a Laotie controller, it's a spare one I had, but for clarity I pulled this one out. You're going to find a black and a red wire that comes directly out of the controller to a 2-pin female connector, and it shouldn't be plugged onto anything. It should be just a loose wire coming out of the controller. This connection has your battery voltage on it. It's never turned off. As long as the controllers are plugged onto the battery, you're going to get the battery voltage here. So you're going to want to find that, again, a red and black wire coming out of one of the controllers going nowhere but to a 2-pin female connector. It's not plugged onto anything. You're going to go ahead and cut that connector off, so you just have a red and a black wire. And then you're going to want to connect that to your red and black wires for the input. Make sure it's the input, 8 to 85 volts of the DC-DC converter. So black wire of that to black wire of there, red wire of that to red wire up there. And then in that point, once you plug the battery back on, Don't do that yet, but when you do, you'll have your negative and positive battery voltage going into the input of this converter. At that point, the converter, there's no switch or anything on it. It will automatically output 5 volts DC on this wire, this cable here, going to the USB. So again, at this point, you still have the battery disconnected from the controllers. You don't want to connect the battery to the very end. So now we have our input connected. We're going to take this output cable. You're going to cut that USB off because we're not using it. You're going to locate your 2 wires. One's going to be black. The other's going to be either red or yellow. I would assume the black is negative, the red or yellow would be the positive. If you have a voltmeter, go ahead and use that to determine which is which. So as luck would have it, this controller that I bought, this one's no longer available. I don't know if I got the last one, but I did go on Amazon and find a different one that will work the same. Different brands are the same thing basically. Same as mine. It has the red, the green, and the white on the output, and the other end has this plug on it that you're just going to cut off so you can get the 2 wires, the plus and minus input to it. So what you're going to need to do next is cut off the connector, strip the wire back so you have your 2 wires. One that will be black, the other will be red or yellow, I believe. Black would be negative, red or yellow would be positive. And you're going to want to connect the black negative wire, that's the input to this, to the black negative wire, which is the 5 volt output of your DC to DC converter. I just hardwired mine, and you can see I got this connection open at the moment. To show you the difference, I cut the heat shrink off, but there's the 2 wires soldered together. I'm going to have to open this up, put another piece of heat shrink on it. You could just use electrical tape or something too, but I prefer to use this heat shrink. It keeps it nice and neat. Connect the red wire from the input of your LED controller to the red wire or yellow, as it may be, the positive coming out of your DC. You can see this one, I've got the heat shrink on it. So I've got my red out of my DC converter going to the red input on my LED controller, and the black input on my LED controller going to the black or negative output of the DC to DC converter. So at that point you have power running to your controller, 5 volts. Again, it's coming from your DC to DC converter, which you've hooked up to that red and black wire that used to go nowhere, just to the 2-pin female connector. So that's your power going into your DC to DC converter. And then the output of the DC to DC converter is going to the input of your LED controller. At this point, if you're wiring up your DC to DC converter to what used to be the Eco Turbo switch to control your halo lights and your side lights, continue watching. This is the start of that part. If you just finished watching the previous part, when you're not using the Eco Turbo switch, you're just wiring these up directly, then you can jump ahead to the time that's shown, which will be showing how to connect the LED strips to your LED controller. I'm going to hook up my DC to DC converter. The input side, I have a black and red wire, so black needs to be negative battery power, and then red needs to go to the switched power. From the switch I'm going to use to control the accessory lights, the side lights, and that point is going to be right here. If you watch my headlight upgrade video, this is where we spliced in the cable for controlling the rings on the front headlights. If you watch that video, you know what I mean. So I'm going to splice into that point there. I'm controlling the voltage now with my Eco Mode switch on this wire here. So this is controlling the rings on my headlights. I also want to put my red wire here for my power for this DC to DC converter that will run the LED. So when power comes on here, this system will turn on as well. I've connected the positive wire from my DC to DC converter to that switched power point. For now, I'm just going to put a piece of tape over it. And then the negative wire to my DC to DC converter, I'm going to put to the black cutoff wire coming out of the controller that we cut off in the headlight upgrade video. If you're going to attempt this, you need to go back and watch the headlight upgrade video, and this will all make sense after that. So anyway, this is our negative battery voltage coming out of here. Just for your information, this used to be a red and black wire coming directly out of the controller with a 2-pin female connector on it. I previously cut this wire to repurpose that cable for running the accessory lights on the scooter. So anyway, again, I'm going to run the negative input of my DC-DC converter to that loose black wire. So now I've got that black wire connected, and I use some heat shrink on that side. Again, later on I'll probably clean this up. I might have to extend the wire once I start putting stuff back in the chassis. So I've just got that taped off for now. So I've got my DC-DC converter hooked up now. I should have power going into it. So now when I turn on my accessory light, which I am now using my Eco Turbo switch as my accessory light. I no longer have Eco mode. I disconnected that in the last video. So anyway, this is now my accessory light. When I turn this on, I get my purple rings on my new headlights come on like that. And that should also turn on my LED strip. So I want to make sure that I'm getting voltage out of my DC to DC converter. So there's my output, 5-volt output. I've got it going to my meter. There's my meter, currently 0 volts. Now I'm going to turn on the push button, push the yellow push button, and you can see I'm now getting 5 volts on the 2 wires coming out of my DC-DC converter. So that's going to be my input voltage to my LED controller. Next I'm going to connect up that 5-volt output from the DC-DC converter to the input side of my controller. It's currently got this plug type pigtail on it. I'm just going to cut this connector off and strip the wires back. Alright, so now I've got my input to my LED controller hooked up to the output of my DC-DC converter. So I got 5 volts coming out of there, red and black going together into my LED controller. So now when I turn on my push button, this controller will turn on, as well as the round lights and the headlights. So now we've got power to this. We simply need to hook this up to a LED strip to make sure it works. So I got 2 different types of strips here. One is non-weatherized, and otherwise it's just the open LED strip. The other one is weatherized. It's in a plastic sleeving. For this project I'm going to use these non-weatherized ones because they have a backing on them that will stick, and so it'll make mounting these a lot easier. Weatherized ones, this rubber coating that they're in, I've tried several different glues and such, and it's hard to find a glue that will adhere to it good, where they won't just easily fall off, and it's because of this rubber coating. I did find Gorilla Glue worked the best, but just for now, for ease of putting these on, I'm going to go with the non-weatherized ones. I had the same type on my Q-Power before. They lasted me a couple of years before I had to replace them. So let's take a look at the input to this one that I plan on using. It's got this plug on it, a red, a green, and a white wire going to the input here. And being LEDs, these are directional too. So you always see the little arrow in the middle there on the DI, and then on this other one, the middle one's DI. Again, it has an arrow. The input has to follow the arrow, so your input side is this side. So now let's take a look at the controller that we're actually hooking up to the LED strip. Now its output side, it has the red, the green, and the white wire. So what I'm going to do at this point is I'm going to cut these 2 connectors off because I won't be using them anyway. I need to run the wires through a hole, and then besides that, I'm going to have 2 separate strips, one on each side, and then I'm going to wire both of those strips into the single output of the controller. So I'm going to need to get rid of these connectors anyway. I've cut the 2 connectors off, and then I just simply hardwired the output from the LED controller to the input of the LED strip, just doing red to red, green to green, and white to white. This is just to test it, so that's why it doesn't look so good there. But I just want to make sure that the LED strip works before I mount them up there, and then I'm going to have to run these wires through some holes on the side of the chassis somewhere. Turn on my accessory light switch, which used to be my Eco Turbo switch, and my 2 round lights should come on, as well as the LED strips. And there's the LED strips. The round lights on the headlight are on. Let's turn them off real quick. Off, LEDs go off. On, LEDs are on. Again, controlling this with my Eco Turbo switch. What used to be my Eco Turbo switch is now my secondary light switch. So now I know this works. I need to just mount the lights and wire them up. Also, this comes with a remote, and you can just set the color of whatever you want. So there's much different colors, and there's different modes you can set it to. So you have the ability to turn them off if you want, or turn them on and have different solid colors, not just flashing. I'm using these smaller LEDs Again, they're not weatherized, but they're smaller. They fit in tighter places. And even with this screw that's going to go through my deck in place, it won't interfere with the LEDs at all. So I can put the LEDs up there nice and tucked away. Still get the screws in without any problem, without hitting the LED lights underneath. And that'll work out pretty good. Should be pretty easy to do. I want to do one strip on each side, going from all the way from the front all the way to the back along the top edge. I've got the strip turned off now, and I'm going to separate my temporary connections there that I was using to test these with. Now I just need to figure out how long I need to make them and cut them off. Good thing about these strips, you can cut them on any of those copper points between the LEDs. I need to make two, one for each side. I decided to just run a strip of lights completely down the sides, starting at the back corner here like this. Okay, so I cut a length for this side, and again you can cut it anywhere along a strip on the copper. I cut it really close to the left side but still on the copper. I did that on purpose because this strip here is going to be the start of the cable for the other side. So I want to leave as much copper on this end as possible. I'm going to have to solder wires onto those copper pads there. So I put mine on the side here. If you do this, be very careful because the scooter does weigh 100 pounds. But be very careful if you do something like this. You don't want it to fall and hit the floor. So anyway, I did this so I could clean up underneath here a little bit better. I'm going to use some isopropyl alcohol and wipe it down good with that before I put the LED strips on. So I just started at the one end, and I wanted to leave enough room where I could have the wires bending around the back instead of this part here. I didn't want to put any stress on that. Work my way from the back, going this way, just pulling the tape off as I go, so you can see I'm up to this point here. Alright, got that side on. And that's another advantage about using this type. The adhesive is really good, it sticks there really good, no problems. And it's going to last on there. So for my light strip on the other side, I need to attach some wires. Unfortunately, I don't have any wires or cables with the red, green, and white colors that I need, but I have this one that has red, black, and yellow in it, so I'm going to use this. The red, well, I'll call the red still, the yellow I'll pretend is the green, and the black I'll pretend is the white. But just got to make sure I keep the colors straight going across this wire. Alright, got my wires connected up over here and everything's working. I was just giving a quick test by connecting up to the output of the LED controller again to make sure it works. Before I put it up on the scooter, I'm going to put some sealant around these connections here. Got that sealed up good now. I am going to put a little sealant on this end here because this place where I cut it is exposed a little bit. I put a dab of sealant on that end, and I also sealed up this end a little bit too, just to hold the wires so there's no stress on the LED strip at all. For sealant on the scooter, I use this stuff here. It's called shoe goo. You can get this on Amazon. So I went back and did the same thing on the other side as well, putting a little bit of sealant on the end of each end of the strip, mainly on the back here to take the stress off of the strip itself. Next, I need to get my LED strip wires inside the chassis. On this side, it's pretty easy. There's my wires just wrapping around the back side, and I'll just have them go in one of these existing two channels that go inside the chassis. On this side there's no openings, so I have two choices. Basically, I could run this cable up along the back here and into one of those two channels like I did with the other side there, but I'd have this cable running along the back up along here. Now the thing is, with the deck on, it wouldn't be visible, so that's not a bad solution to just run over to that channel there. However, I think I'm going to actually just drill a hole somewhere in this area, try to drill through this chassis, and then run the cable on the inside where I can take it over there and hook it up to the other set of wires. So I'm starting with the smaller size drill bit, 7/64. If you're going to be doing any drilling on this chassis, I believe it is steel chassis, I suggest getting these cobalt bits. They seem to work pretty well. So you notice I did take my controllers out of the way. I didn't want to accidentally drill into my controllers and clear any wiring or anything that might be in your way there. Now I put a hole all the way through with the 7/64 drill bit. It does take a while. Give it full speed and don't press too hard. Let the drill bit work. Now going up to a 3/16 inch drill bit, and I'm going to widen the hole. This should be enough to get the cable through, I think. So as you can see, it does take a little work. Let the drill bit do the work and cut through it. I filed the hole down a little bit using my file to make it smoother, and then vacuumed up. I had some metal shavings inside the chassis. I just vacuumed up. But before I put the cable through there, I want to protect these wires a little more, so I put a piece of heat shrink tubing on here that I'm going to slide up. Okay, so that's pretty good. I have my cable going through the hole there, so now it's on the inside, or I can run along the back on the inside to get it to where the other wires are from the other strip. So I have the two strips tied together now. Again, I just took my cable from the other side, which I used the red, yellow, black wires, red for red, yellow for green, and black for white. Connected them to my wires coming from my other strip here, of course the red, the green, and the white. So I had those two connected together. Now I just need to connect these up to the LED controller. I have my two light strips tied together, and then going to the output of my LED controller. So I got the red, green, white coming out of the LED controller, going to the red, green, and white of the two LED strips. I should be able to turn on my accessory light switch now and have the strips on both sides come on. Good, they come on this side. My two halo lights on the front are on. And they're on this side as well. I put it down on the ground here and darkened it off so you can see a little bit more what it looks like. I don't really have my deck on yet. It's just kind of laying there because I'm going to be doing some more stuff inside. This gives you a good idea what it looks like. Can't see any of the LEDs on the side unless you get down real low, or maybe if you are off in the distance a little bit. Again, you have full control using remote control, so if I want to turn them off, I can turn them off, back on, change the colors, and so forth. And then there's a bunch of different modes to it. Okay, that's it for this one, guys. If any of you are going to try this and need any help, drop me an email. I'll be doing some other videos coming up here shortly. A couple more things I want to do this before I start riding it. So until then, guys, take care, peace, ride safe.